Welcome back, everyone. Today, we're taking a deep dive into the world of human augmentation.
Yeah, we're going to be exploring how neuroscience is being used to, well, boost our abilities, push the boundaries of what we thought was possible, really.
We've got two academic papers to dig into today.
One's really focused on the technical side of these advancements, and the other one looks at how the public feels about them.
It's fascinating stuff, you know?
Yeah.
I mean, imagine communicating directly with another brain,
Or enhancing your memory.
or even influencing decision-making.
It really raises a lot of questions.
Definitely. So let's start by understanding the landscape a bit.
Sure. I mean, when we talk about human enhancement, we're talking about a pretty wide range of things, right?
Yeah, everything from performance-enhancing drugs to advanced prosthetic.
Brain-computer interfaces, all sorts of things.
But for this deep dive, we're going to zero in on cognitive enhancement.
Right. So that means improving things like attention, memory, learning.
Decision-making, and even communication.
Right. Now, to do that, we need tools. And neuroscience has given us a whole bunch of technologies for both recording and influencing brain activity.
Some of these are probably familiar to people, right? Like EEG and fMRI.
Yeah, those are kind of the workhorses.
Uh-huh.
EEG gives us those brainwave readings, and fMRI gives us those detailed maps of activity in the brain. But there are others, too, like FNIRS.
FNRS. What's that?
It uses light to measure blood flow in the brain, so it's a really clever way to track which regions are active.
Without needing all that bulky equipment.
Exactly. And then there's MEG. That one captures the tiny magnetic fields generated by brain activity. It's super precise.
It's incredible how far we've come in our ability to listen to the brain.
It is, but it's not just about listening anymore, is it? We can actually influence brain activity now, too. Techniques like TES, for example, they use weak electrical currents to potentially boost memory, attention, or even motor skills.
Really? Just weak currents. That can actually have a noticeable effect.
Yeah, it might sound a little strange, but it shows some real promise. It's kind of like giving your brain a gentle nudge in the right direction.
I like that analogy, a gentle nudge. What about other techniques?
Well, there's TMS. That uses magnetic pulses. It's been used to treat things like depression.
I've heard about that.
Yeah, and it's also being explored for boosting creativity and problem solving.
Wow. And then there's FUS, right?
Ah, yes, focused ultrasound. That's a newer one.
Uses sound waves to stimulate brain circuits.
Right, but non-invasively. So as you can see, we have a whole spectrum of tools now, from gentle nudges to more targeted approaches.
And what can we actually do with all this technology? What are the practical applications?
Well, that's where it gets really interesting. I mean, think about brain-computer interfaces, or BCIs.
Those are the ones that allow paralyzed patients to type messages or control robotic arms, right?
Exactly. And we've already seen some pretty amazing things achieved with BCIs.
Well, it seems like we're on the cusp of something even more revolutionary.
Oh, you mean brain-to-brain communication?
Yeah, is that even possible?
Well, it might sound like science fiction, but research is already exploring it. There have been studies where information was transferred between the brains of rats.
Between rats, wow.
Yeah, and they were even able to transfer knowledge about specific tasks.
That's incredible. What about humans? Have they tried that with humans yet?
There have been some experiments with non-invasive techniques like EEG and TMS.
What happened?
They were able to achieve a limited form of communication.
Like what?
In one study, participants used a brain-to-brain interface to play a collaborative game. So they were sending signals to each other to guide their actions.
So it's not quite telepathy, but it's a step in that direction.
It's definitely a step in that direction. It's still early days, but the implications are pretty profound.
It really makes you wonder where this is all going. I mean, what if this technology becomes widely available?
Right. It's pretty mind-blowing to think about.
But communication is just one application, right? What about directly boosting our cognitive abilities? Can these technologies actually make us smarter?
Well, there's mounting evidence that they can. Studies using TDCS and TMS have shown improvements in things like visual search and threat detection.
So we're talking about making people more alert, more aware of their surroundings.
Exactly. And that has obvious implications for people in high-stakes situations.
Like military personnel or even drivers, right?
Exactly.
This is starting to feel like something out of a superhero movie. But let's stay grounded for a moment. What about memory?
Ah, memory. That's a big one.
Yeah, I mean, it's something that fascinates a lot of people, especially with concerns about age-related decline.
Right. And there's a lot of research going on in that area for precisely those reasons. Studies using TDCS have shown improvements in working memory.
Working memory, what's that exactly?
It's basically that mental scratch pad we use to hold information while we're solving problems or making decisions. It's crucial for all sorts of everyday tasks.
So TDCS could help us keep more information in mind at once.
Potentially, yes. And for those with more severe memory problems, there's research using DBS.
DBS, that's the one where they implant electrodes in the brain.
Yeah, it's more invasive, but it has shown some promising results for memory improvement.
Even though it involves brain surgery.
Yes, it's a big decision, of course. But for some people, it could be a game changer.
It's pretty remarkable. But let's shift gears a bit and talk about attention.
Okay, attention.
Because that's something we all struggle with from time to time, right?
Mm.
I mean, can these technologies really help us focus better, minimize distractions?
They absolutely can. Researchers are actually developing systems that monitor things like workload and attention levels in real time.
So you could have a device that tells you when your mind is wandering.
Or when you're approaching mental overload. It's like having a personal mental coach, you know?
Wow. What could we achieve if we had that kind of insight into our own minds?
The possibilities are really vast. Imagine adaptive interfaces that adjust to a user's mental state.
Like a computer system that detects drowsiness in a driver and issues an alert.
Exactly. Or a system that adjusts the information flow to an air traffic controller's workload to prevent cognitive overload.
We're talking about potentially saving lives here.
Absolutely. And it goes even further, into the realm of situation awareness.
Situational awareness.
Yeah, it's the ability to quickly assess and respond to complex dynamic environments. It's crucial in fields like aviation, military operations, emergency response.
Where split-second decisions can have huge consequences.
Exactly. And EEG studies have actually been used to detect changes in brain activity when someone loses situation awareness.
Really? So you could have a system that alerts people to potential dangers before they even realize they're losing focus.
That's the idea. It could be a real game changer for safety and performance in those high-stakes fields.
This is powerful stuff. But before we get too carried away with all the incredible potential of these technologies, we need to address the elephant in the room.
What's
the human factor? People are complex, and we don't all respond to things in the same way.
Right, you're talking about individual differences.
Exactly. Won't that impact how these technologies are developed and adopted?
Absolutely. We can't just assume a one-size-fits-all approach will work with cognitive enhancement. Things like genetics, age, personality. They can all influence how someone responds to these technologies.
So some people might see huge benefits, while others might experience minimal effects, or even unintended consequences.
That's right. It's not as simple as just plugging everyone into a brain-boosting device and expecting them to become superhuman.
Right. So we need to understand those individual variations and tailor the application of these technologies accordingly.
Exactly. Researchers are actually exploring this concept of participant selection. They're using individual performance profiles and group dynamics to try to figure out who's most likely to benefit from a specific technology.
It's like personalized medicine for the brain.
That's a great way to put it.
And that brings up another important point, training.
Ah, yes, training. Can't forget about that.
Even with the most advanced technology, you still need to learn how to use it effectively, right?
Absolutely. Imagine trying to control a robotic arm with a BCI without any practice.
Yeah, it would be a disaster.
Exactly. But what's really interesting is that we can use neuroscience itself to improve training methods.
How so?
Well, researchers are using EEG-based feedback to create training simulations that adapt to an individual's brain activity. So it's like the training is personalized, too.
That's amazing. It's like having a personal trainer for your brain, guiding you towards optimal performance.
Well, that's a great analogy.
And if we can enhance our ability to learn and adapt, that opens up so many possibilities, not just for specific tasks, but for our overall cognitive potential.
It's an exciting time to be in this field, that's for sure.
It feels like we're at a turning point where science fiction is becoming reality. It's both exhilarating and a little bit daunting.
I agree. The future of human augmentation is full of promise, but also full of challenges. It really is. And as with any powerful technology, there are, ethical and societal questions we can't ignore.
It's like we're opening up this treasure chest filled with all these incredible jewels, but there might be a few booby traps hidden in there, too.
Yeah.
Where do we even begin to unpack all the ethical implications of this stuff?
Well, one major concern revolves around safety, especially with these brain stimulation techniques.
Right.
I mean, while non-invasive methods like TES and TMS are generally considered safe for short-term use, We need more research to really understand the long-term effects, especially with repeated or prolonged stimulation.
Yeah, it makes sense to be cautious. We don't want to create a society of like enhanced individuals who end up facing all these unforeseen consequences down the road. And what about, invasive techniques like DBS where electrodes are implanted in the brain?
Right.
The risks and ethical considerations there seem even more complex.
Absolutely. I mean, any procedure that involves like altering the brain, we have to carefully weigh the potential benefits against the potential harms.
Right.
And really prioritize informed consent.
Informed consent, yeah. And that leads us to another big concern. Privacy.
Privacy, right.
If these technologies can actually read and influence brain activity, are we opening the door to a world where our thoughts are no longer our own? I mean, is mind reading a legitimate concern here?
It's understandable why people are worried about that, but it's important to remember that, current BCIs require conscious effort from the user. They can't just like tap into your thoughts without your cooperation. It's more like learning a new skill, You have to train your brain to communicate with a device.
So it's not like those, sci-fi scenarios where someone can just like scan your brain and download all your secrets.
No, not at all.
There's still a level of control involved.
Exactly. But, as the technology advances, the potential for misuse or unintended consequences, well, that's going to increase too. That's why it's so important to develop these ethical guidelines and regulations to protect people's mental privacy, their autonomy, as the field progresses.
It's almost like we need a new set of digital rights, but for our minds. Like the right to mental privacy. The right to not have our thoughts manipulated without our consent.
Yeah, I mean, you're talking about some pretty fundamental aspects of what it means to be human, right?
Exactly. And it goes beyond just privacy, doesn't it?
Yeah.
These technologies also raise questions about agency and responsibility.
Right. If someone's actions are influenced by an augmentation technology, who's ultimately responsible? Is it the individual? Is it the person who developed the technology, the person who programmed the device? It gets really tricky.
It's a tough one. It kind of reminds me of the debates about self-driving cars. If the car crashes, who's to blame? These technologies are kind of blurring the lines of responsibility, and it feels like our legal and ethical frameworks are, well, they're struggling to keep up.
Yeah, it's a rapidly evolving landscape, and we really need to have these difficult conversations about how to adapt our systems as these technologies become more integrated into our lives. And there's another crucial aspect we have to consider: equity and access.
Right.
I mean, if these brain-boosting technologies are really expensive or only available to certain groups, won't that create new forms of inequality and social division?
It's a very valid concern. We already see these disparities in access to things like healthcare and education.
Right.
And it's not hard to imagine those gaps widening if cognitive enhancement technologies become a reality.
Exactly. We need to be proactive and address these ethical concerns now.
Yeah.
Before these technologies become so widespread that we can't control the potential consequences, if we're not careful, we could end up with a world where the advantages of cognitive enhancement are only available to like the privileged few.
It feels like we're at a real crossroads here. We have these incredible tools that could potentially improve lives in so many ways, but we need to make sure we're using them responsibly, ethically. We've talked about a lot of these big picture ethical concerns, but let's shift gears for a bit and talk about some of the practical challenges of implementing these technologies.
Okay.
Training is one that comes to mind. I mean, even with the best technology, people still need to learn how to use it effectively, right?
Absolutely. Training is essential. Imagine someone trying to control a robotic arm with a BCI without any prior practice,
It'd be chaos.
Exactly. But the exciting thing is that we can actually use neuroscience to develop more effective training methods. For example, researchers are using EEG-based feedback to create training simulations that adapt to an individual's brain activity. So it's like, personalizing the learning process.
It's like having a personal trainer for your brain, guiding you towards optimal performance.
That's a great way to think about it.
And if we can enhance our ability to learn and adapt, that just opens up so many possibilities.
Right.
Not just for specific tasks, but for our overall cognitive potential. But training is just one piece of the puzzle.
Yeah.
What other practical hurdles do we need to consider when it comes to implementing these technologies?
Well, one that often gets overlooked is user friendliness. You know, we can develop the most sophisticated brain-boosting gadgets in the world, but if they're clunky, uncomfortable, or difficult to use, people just won't embrace them.
It makes sense. It kind of reminds me of the early days of personal computers. You know, those
Yeah.
big beige boxes with the complicated interfaces.
Right.
It took a while for them to evolve into those sleek, intuitive devices that we're also accustomed to today.
Exactly. We need to think carefully about design, ergonomics, user experience. If we want these technologies to be widely adopted, they need to seamlessly integrate into people's lives.
It's not just about the science, it's about the design, the human element, how these technologies will actually be used and experienced by real people.
Precisely. And that requires a really collaborative approach, bringing together neuroscientists, engineers, designers, even ethicists, to ensure that these technologies are developed in a way that's both beneficial and appealing.
It's like building a bridge between the world of science and the world of everyday life. And that bridge needs to be strong, safe, and, well, aesthetically pleasing if we want people to cross it with confidence.
That's a great analogy.
So we've covered a lot of ground here, from the awe-inspiring potential of these technologies to the ethical complexities, the practical challenges that come with them. It's clear that we're at this pivotal moment where science fiction is becoming reality. But it's up to us to navigate this new landscape thoughtfully and responsibly.
You're absolutely right. The choices we make today will shape the future of human augmentation, for better or for worse.
We've talked about enhancing memory, attention, all these things. But what about something as complex as problem solving?
Problem solving.
Can these technologies actually help us think more creatively, make better decisions, maybe even unlock new levels of cognitive performance when it comes to tackling these complex problems?
It's a fascinating area of research, and while it's still in its early stages, there are some intriguing findings that suggest certain brain stimulation techniques could enhance those abilities.
Oh, really? Give me an example. How could these technologies actually boost our brain power in that way?
Well, one study used TDCS to improve performance on a classic test of creative thinking called the Remote Associates Test. It's where participants have to find a fourth word that connects three seemingly unrelated words.
Like finding that missing link that ties everything together.
Exactly. And TDCS actually helps people make those creative connections more easily.
Wow, that's pretty cool. What else?
Well, in another study, TDCS enabled participants to solve a notoriously difficult spatial puzzle, the kind that often leaves people feeling, stuck and frustrated.
So we're talking about breaking through those mental barriers.
Right.
Finding solutions that might have eluded us before. Could this be the key to, unlocking new levels of innovation, problem solving across all sorts of fields?
It's certainly a possibility. It's as if TDCS can nudge the brain into a more flexible, creative state, allowing us to see problems from new angles, come up with novel solutions. But before we get carried away with these dreams of becoming super solvers, it's important to acknowledge that there are, potential downsides, trade-offs to consider.
That makes sense. What kind of trade-offs are we talking about?
Well, one concern is that enhancing one cognitive function might come at the expense of another. For example, some studies have suggested that enhancing focus might actually reduce our ability to think broadly and creatively.
So it's like that classic trade-off between speed and accuracy. You might be able to process information faster, but you also increase the risk of making mistakes.
Right.
Or in this case, you might gain laser focus, but lose some of your creative flexibility.
That's a good analogy. It highlights the need for a balanced approach, We need to understand these potential trade-offs and make sure that we're not sacrificing essential cognitive abilities in our quest for enhancement in other areas.
It sounds like a delicate balancing act. And we need a lot more research to really fully understand the long-term effects of these technologies and how to use them safely and ethically. But overall, it feels like we're standing on the precipice of this new era, where we have the potential to enhance human capabilities in ways that were once, just the stuff of science fiction. Where do we go from here? What are the big questions that we need to be asking ourselves as we move forward?
I think the most important question is, what kind of future do we want to create? Do we want a world where cognitive enhancement is accessible to everyone, or will it become a privilege that's reserved for the few?
That's a fundamental question, and it ties into so many of the other issues that we've discussed: ethics, equity, access, responsibility.
Exactly. And ultimately, it's up to us to decide how we want to use these powerful tools. Will they be used to promote human flourishing, to create a more equitable and just society? Or will they just exacerbate existing inequalities and lead us down a path we might later regret?
These are some really profound questions. They demand careful consideration and open dialogue as we shape the future of our species.
It is, isn't it? It's humbling. We're not just like tinkering with technology here, are we? We're shaping the future of humanity.
No kidding. And that's why these conversations are so important, right? We need to be having them now while these technologies are still being developed so we can at least try to steer them in a direction that benefits everyone. I keep coming back to this idea of enhancement, though. What does that even mean in the context of these technologies? Are we talking about making people, better, smarter, more productive? Like, what are we even striving for here?
Yeah, that's the core of it all, isn't it? I mean, the very idea of enhancement, it's subjective,
Right.
What one person considers an improvement, another might see as totally unnecessary or even undesirable,
Right.
And who gets to decide what's better anyway?
Yeah, that's a good point. It's like trying to hit a moving target. The definition of enhancement is probably going to keep evolving, right?
Yeah, definitely. As these technologies develop, as we learn more about the brain, I think that's really key here, actually. This isn't just about finding some technological solutions. It's about, expanding our understanding of what it means to be human, really.
Right.
How do these technologies impact our sense of self, our relationships, our place in the world? These are questions that, well, they go way beyond science. They get to the very core of our human experience, I think.
It's a lot to wrap our heads around, that's for sure. But, that's what makes this whole deep dive so fascinating. We're not just exploring these technologies, are we? We're wrestling with these profound questions about who we are, who we want to be.
Exactly. And that's why it's so important to approach this whole field with a sense of both excitement and caution, I think.
Yeah, I agree.
We need to be mindful of the potential benefits, for sure, but also aware of the risks, the ethical considerations.
Right. We need wisdom, not just innovation. This has been an incredible journey, really, exploring the frontiers of neuroscience and this whole idea of human augmentation. It feels like we've only just scratched the surface of what's possible. And it's both exciting and a little bit daunting to think about what the future holds.
It really is a time of great transformation. And as we continue to unlock the mysteries of the brain, as we develop these powerful tools, well, it's up to all of us, isn't it, to make sure that we're using them wisely, ethically, for the benefit of all humanity.
Couldn't have said it better myself. Thanks for joining us on this mind-expanding adventure, everyone. And until next time, keep exploring, keep questioning, keep pushing the boundaries of what's possible.